Alrighty, so we are going to keep on talking about language. So we left off on this diagram in the last class. So we've been looking at the different parts of the brain that are involved in sort of listening to and producing language. We had also mentioned that our visual cortex, that in the occipital lobe, that primary visual cortex, would be involved in seeing sort of written language. And then we talked about sort of our primary motor cortex involved in the production of language, including our hand gestures. And so today what we're going to do is start looking at some of the actual sort of data from real studies. So we're going to be looking at the same basic setup, but from an actual brain imaging study. So this is a set of PET scans. So if you remember back to our talking about the different types of brain imaging approaches, this is a PET scan. It's showing activity in different areas. And the way that they would do this is they'd probably do a bunch of control trials just to get a feel for different levels of brain activity in different parts of the brain unrelated to what they were looking at. So how does your brain look when you're just sitting there doing nothing? If you're not hearing anything, if you're not seeing anything, so that they can subtract out that baseline. And then they'd be looking at how does that change when you're exposed to different things. So the first is looking at hearing words. So that's going to be involving our auditory or primary auditory cortex, as well as our Wernicke's area in the middle where we're understanding speech. Seeing words is going to activate that occipital lobe at the back. Speaking words gets our Broca's area and our primary motor cortex involved. And then generating words is going to be involving sort of just ahead of our Broca's area, but it's getting our prefrontal cortex involved. And that kind of makes sense because we're putting together concepts. So we're going to be using sort of more of our complex areas, bringing things together in order to then produce those words. So the Broca's area and in advance of it. And then, of course, when we're talking about sort of which areas are involved, people inevitably start asking, okay, well, are there differences between groups? And so one of the biggest things people focus in on is, are there sex differences? And this is another thing that we kind of mentioned briefly in passing in previous chapters. So we mentioned that we see a slight difference in our hemispheric lateralization in males versus females. So we had said that males tend to have a sort of greater lateralization of language ability. And all this means is that in males, the left hemisphere is more strongly related to language, and the right hemisphere not so much. But in females, we tend to see almost equal activity in both hemispheres. So they are non-lateralized for language. So we might say that we have bilateral activation, meaning that both hemispheres activate in females when sort of hearing and producing language. And the implications of this is that if males suffer brain damage, if it damages the left side of their brain, it's a lot more likely to lead to aphasia, so difficulty either producing or understanding speech. And yet in females, that ability tends to be more intact, probably because there's some redundancies where some of those language controls are going to be over in the right hemisphere as well. So damage to the left hemisphere is less detrimental. And we can actually, again, look at real data, this time from fMRIs, so still showing brain activation, but a slightly different scanning technique. And so we see that when males are, hearing language in that situation, they are having almost exclusively left hemisphere activation, and the female brain is showing bilateral activation, so both hemispheres are involved. So it's kind of nice to be able to talk about the concept, but also show actual brains and brain activity that shows those concepts. All right, so now that we've talked about what language is, some of our important terms, and we've also gone into, okay, what parts of the brain are involved in producing and understanding it, how do we actually acquire language? How do we learn to read and speak or sign? And I've mentioned that a lot of the literature focuses in on spoken language, and so does our textbook. But a lot of these concepts, a lot of the rules that we're going to be talking about also apply to other kinds of language, whether it's written or signed. But just due to limitations of research, we focus in on spoken. So we can look at our milestones in language development. And with developmental psychology, we basically like to look at how people progress from birth onward and sort of where they tend to be ability-wise at different ages. So for language development, we'd be focusing on what are individuals typically capable of at different sort of milestones, at different ages. So we see that at birth, we have our initial vocalizations, and this would be crying and cooing and babbling. Now, babbling is the one that we care most about, and that's because babbling is going to be the production, pretty much the random production of sounds. And I mentioned earlier on that when we're born, we're actually going to babble and produce all possible phonemes. So we're not just going to produce the sounds that are in our native language, the language that our parents speak. We're able to produce sounds that are used for all possible languages. So it's not until we get older that we'll specialize on a language. At birth, we have pretty much the same vocalizations no matter what your parents speak. So this gives us some indication that those initial vocalizations are going to be the same pretty much around the world. And we had mentioned that children aren't necessarily restricted to only learning the language that their parents spoke. By exposure, they can be taught any language. By the time we get up to 6 months of age, that babbling begins to take on a slightly different form. So we're going to see more of the sounds that are involved in the language that we're exposed to. So that surrounding language would be the thing that we learn to speak first, probably what's spoken by our parents or guardians. And we're going to drop those sounds, those phonemes that aren't used by that language. So as we get a little bit older, it becomes harder and harder to learn those other languages, just because we don't produce those sounds anymore. By the time we get to 1 year of age, we start seeing our first words, and we have another cross-cultural similarity here. This one is probably a lot less due to, say, a biological underpinning. So when we're born and can produce all possible sounds, because we don't have any experience at that age, it's probably just a genetic predisposition. But our first word is probably very heavily influenced by the fact that our parents talk to us and are usually repeating whatever we're going to be calling them. So the first word in most languages for children is going to be the word for parents. So mom, dad, or mama and dada are going to be the ones that most children say regardless of their language. And we start seeing this distinction between what's called receptive language and expressive language. And I tie this back again to our learning a second language, just because we don't remember learning our first language. We were too young to have that memory. But you were probably forced to take a second language in school. So you have some memory of being exposed to a second language at a fairly young age. But as I said, my pandemic hobby has been relearning French, and I find that my receptive language, my understanding, is a lot better than what I can produce, than my expressive language. So I can do a decent job of seeing a written statement or hearing a phrase and getting the basic idea of what's going on. But I have a lot of trouble producing a grammatically correct sentence. So my receptive language is decent. Expressive language, not so much. And that's true for even our first language. So children, you'll find they're able to produce a small subset of words, but if their parents tell them to do something or not to do something, which might be more likely, they're able to do a lot more than what they could talk about. So that's that distinction between receptive, that understanding, and expressive, the ability to produce. So there is sort of a disconnect there. And so keeping on, we get into our 18 months to 24 months. And so it's sort of a year and a half to 2 years. And this is when we see a pretty massive vocabulary spurt. This is basically saying that we're starting to learn words very, very rapidly. Around this age, we might be learning as many as 20 words a week. And they have some specific numbers. I included a graph for this, but it ended up at the end of the slides instead of the beginning. But when we're in grade 1, we can speak about 10,000 words. That's our vocabulary. But by the time we hit 5th grade, we have a sort of a 4-fold increase. We can speak up to 40,000 words. So that is a massive jump in vocabulary. Over that period, you're learning about 10,000 words a year, which is massive. And this is actually one of those points that we're going to sort of come back to when we're talking about evidence for biological underpinnings of language acquisition, because acquiring that much that quickly, we must have something that sets us up to be able to do that. We typically don't learn anything that quickly, so we must have some kind of system in place to help us do so. During this rapid period of growth, though, we also see something called overextensions and underextensions. And this is basically saying that when we're learning new words, we don't necessarily apply them correctly. So an overextension would be when we incorrectly use a word to describe a wider set of objects than we should be using. So maybe we've learned that our cousins have a dog, and that dog's name is Bob, because I love dogs with human names. And so that kid gets used to seeing Bob, and when they see another dog, they might say Bob too, assuming that all dogs are Bob. And as hilarious as that would be, that's not the case. So they were overextending, they were applying that name to more than it should have. An underextension would be the opposite direction. So maybe they know the term dog for talking about dogs, but maybe they don't include all dogs under that umbrella. So maybe they see a Chihuahua and don't realize that it is a dog too, so they'd call it something else. So we can have sort of issues with applying all of these new words because we're learning them so quickly that usage might be a little bit behind. By the time we get through our 2nd year, we start combining words. So up to this point, we typically see sort of single words at a time. A lot of communication is going to involve gestures. So they'll point and say things, but it's usually sort of 1 or 2 words at a time, mostly 1, lots of gestures. By the time our 2nd year passes, we get into combinations of words. And specifically, we start seeing what's called telegraphic speech. And this is when these children are sort of boiling down a concept into the most basic form. So maybe they're going to say, want cookie, or give block. So it's a verb and it's the noun, and that's all they're getting across, but it gets their idea out. And the reason it's called telegraphic speech is because when people communicated by telegraph, you paid per letter. So you would say things as concisely as possible. So you'd get rid of proper grammar in order to get the point across. So you would have a verb and a noun, and not much else. So that's where the name came from. And as we sort of start moving on here, if you ever look at data that's trying to quantify sort of complexity or language ability, you might see it expressed as mean length of utterance, or MLU. And that's just a fancy way of saying how long are the phrases that the children typically use at that age. So as I said, when they're much younger, they use sort of maybe 1 word at a time. Getting into just sort of 2 years and beyond, they have 2 words or more. And as they get older and older, they'll have longer and longer utterances. So their phrases will get more complex and involve more words. So what we would probably see is an exponential curve where at the beginning there's sort of slow growth in the length of those phrases, and then it can skyrocket and you can say entire sentences or sort of long paragraphs all at once. And then again, continuing on into our third year and beyond, we start seeing more complex ideas. We're going to see the addition of plural and past tense when looking at grammar. So we're not just looking at the here and now, we're starting to sort of add to that more complexity. We do see, again, issues here being over-regularization. And this is especially common in English because we have a lot of grammar rules that don't apply to everything. So if a child is talking about a mouse and now there's 2 mice, they might say that there are mouses. That would be an over-regularization because they're using technically the correct grammatical extension, but it doesn't apply to that word. Same thing with past tense. So maybe they talk about they just came back from the store. So they would say that they goed to the store. It's like, well, technically kind of, but you went to the store. And so those extra ideas take a little bit more time to sort of sink in for them. So they learn the rules before they learn the exceptions. And so this table does a great job of summarizing some of the sort of key points that we've hit. We went all the way down sort of to the sort of 3.5 years of age. Into the 4, 5, and 6, we're just saying longer sentences, more complex syntax, and eventually this metalinguistic awareness is that ability to have sort of more complex concepts represented. So things like things that will happen or things that could happen. Considering the theoretical. And if you ever look at developmental studies, so if you go on into 105 and they talk about development across the lifespan, there's this weird thing where they ask children to imagine how their lives would change if they didn't have thumbs. And younger children have no concept of how that would adjust anything. But older children realize that if you don't have thumbs, you can't grasp the same way. So they'd have to change how they interact with objects. But there's sort of this line where before that, there's just no way to represent that. And after they pass that milestone, all of a sudden, they're a lot better at these sort of theoretical concepts. So we start seeing a change at that point. All right, and so another one of those sort of continuing on with things that we've talked about kind of ad nauseum throughout this course, when we're talking about a particular trait, here our trait being producing language, we always have that debate of, is it something that's biologically controlled? Is it due to our genes? Or is it something that's environmentally controlled? Is it due to experience? And so, of course, by now we know that there are going to be people in opposite camps. So we have some people who say it's entirely biological. We have some who say it's entirely environmental. And then by the end of it, we settle somewhere in the middle where we find a happy medium. So let's start with those who are focused in on these biological foundations. And so we're going to look at some evidence that actually goes along with yes, there is some kind of biological component. So as we mentioned, I guess we didn't go into this much detail, but yeah, children are going to learn language without formal instruction. So they don't have to go to school to learn to speak a language. Just hearing their parents talk is enough for them to learn to speak themselves. So we don't have to have formal instruction to pick up on it. We also start seeing commonalities among different languages. And the logic here is that while some languages share similar roots, so say we have the Romance languages, so we have French and Italian and Spanish that all have very similar roots. So there's some parallels there just due to sort of common derivations of the words. But there are also sort of very, very different families of languages that have nothing to do with one another. And yet concepts are still discussed in the same basic ways. So all languages have a common deep structure. And the way we see this is we can actually translate a concept between languages. We can talk about things in French and in English and in Cantonese. There are all sorts of different ways to represent it. The surface structures can all be different, but the deep structure is the same. And that commonality tells us that maybe there's something biological, there's something in our genes that sets us up to have that understanding. On that sort of commonalities, our infants can vocalize all possible phonemes. We're not just good at producing our own. And then we do see that our ability to discriminate between phonemes starts to shift based on which languages we speak. So as we get older, as we drop some of those phonemes, as they become irrelevant, we stop attending to them. So we had that ability to produce it, but as it's been irrelevant, we start ignoring it. So we kind of advance from there. And so there's lots of different studies that will look at, say they'll get a bunch of people to come in, put on headsets, and you'll have to make discriminations between sounds. Are they the same or are they different? And if it's a sound that is used in your own language, you're really good at telling apart even very similar sounds, as long as the differences are relevant. So if the language that you speak pays a lot of attention to inflections, so a very slight difference in pronunciation changes the meaning, then you're going to be really good at that discrimination. But for someone else where that doesn't matter, they're conceptually treated as the same and they can't make that discrimination. And there's lots of really cool research that looks at stuff like that. So we're really good in our own language and terrible at everything else. And so all of this biological evidence was sort of the starting point for our big name and biological, or I guess genetic underpinnings of language, and that's Noam Chomsky. So if you've ever talked about language acquisition, you have probably heard that name before. And so he proposed that all of our ability to acquire language came from some kind of genetic factor, some kind of biological mechanism that set us up to be able to acquire language. And he called this his language acquisition device. So he was looking for a very specific mechanism that could explain all of our language acquisition abilities. And so he thought that we had sort of some kind of underlying thing that set us up, that sort of all these rules would follow and everything would sort of magically come together. Since I'm not going to teach you about a language acquisition device, you might imply that, yeah, while the idea, the concept behind it, yeah, there's probably some biological component, we haven't found what we would call a language acquisition device. We can't point to a single mechanism or a single structure and say, here is where language happens. Instead, it's a lot more complex of a process. So that's us saying, okay, well, there is some evidence for biology, but it's not everything. All right, so what about the environment? What evidence do we have for that social aspect of learning? And even just from our own experiences, we probably know that there's probably some social involvement going on. Our parents, or I guess most texts will talk about parents, but this is guardians or anyone that a child interacts with regularly. If you spent a lot of time with a babysitter, that would be someone who is influential in your language acquisition. But again, across multiple cultures, we see what's called child-directed speech. And these are very high-pitched intonations that are directed at children. That's the scientific way of describing baby talk. And so people tend to speak in a very specific way, in a higher pitch, while making very extreme eye contact with children. And if you sort of stop and think about it, it's very odd behavior, but there maybe is some biological underpinnings for us to do that when we see children. And the idea here is that strange pitch and intense eye contact is meant to get the child's attention and hold it while you speak to them. And most of what we talk about when interacting with children, especially young children, is going to be naming objects and asking questions about things that they're currently doing or things that they're currently interacting with. And so the idea here is if a child is playing with their stuffed bear, you're going to ask them about their bear. You're going to say, is that your bear? Do you like playing with your bear? And so they're going to start hearing particular phrases while they're doing particular actions. So they're going to realize that those sounds are the thing that they're touching, that they're interacting with, that they're near. So they start learning those things just due to sort of collective exposure. And this should start make us thinking about some of our learning processes. So in our chapter on learning, we started talking about how things being presented together, as well as sort of the actions that follow a particular behavior, can change what we know. And so we're going to actually come back to B.F. Skinner, who was our resident behaviorist, and who was actually an extreme behaviorist because he had that sort of confrontational opinion that operant conditioning on its own could explain any human behavior, including language. So he had said that all of our language acquisition could be completely explained through operant conditioning and operant conditioning alone. There's no need to assume any kind of biological pre-programming. And so the idea here, again, makes logical sense. We get positive reinforcement of appropriate language. If a kid picks up a bear and says bear, their parents are going to praise them. Yes, you've got it right. If they pick up their stuffed bear and say mouse, then the parents are probably going to correct them or maybe ignore them because it's not correct. So we get non-reinforcement or correction of inappropriate language. So that sounds an awful lot like differential reinforcement, reinforcing the right thing and not reinforcing the wrong thing, and also maybe a little bit of shaping, getting them to do the right behavior over time. So it kind of makes sense that, yeah, operant conditioning might have a role in learning. However, of course, as this was proposed, people would then go on and test it. And we've pointed out children learn words very quickly. And I mentioned earlier on that the rate at which they learn, it's too quickly for sort of what we would normally be able to learn. So we have a certain rate at which we can acquire concepts using things like operant conditioning, but children learn so much more quickly than could be explained by operant conditioning alone. It's just too exponential of a growth curve. So it's far beyond what they theoretically could learn. And then in studies that looked at actual parent-child interactions, they found that there isn't enough evidence for that operant conditioning, especially when it comes to things like grammar. So when children interact with their parents, as long as the thing that they're talking about is sort of correct in terms of meaning, if the deep structure is correct, the parents tend not to correct their grammar. So if the surface structure is wrong, but the deep structure is right, the parents tend to agree with the child and say yes. So if the child has just come back from the park and said that they goed to the park, the parents would probably say, yes, yeah, you went to the park. But if they said that they goed to the movies, but they actually went to the park, then the parents would be more likely to correct them. And so we see this correction of meaning and correctness, but not of grammar. And yet, despite not correcting grammar, we do still acquire correct grammar eventually through exposure alone. So that's saying that, yes, there might be some contributions of operant conditioning, but it's not everything. And so if we're focusing on these environmental factors, we can look at they've found a new acronym to match the first, the Language Acquisition Support System. And they really, really twisted that one so that we have LAD and LAS. But this represents social factors in the environment that facilitate language learning. So if the LAD is focusing on biological or genetic factors, LAS is focusing on sort of social support and environmental factors. And so, again, we don't necessarily have a single mechanism that we can point to, but we do have some support for, operant conditioning plays a role, social interaction plays a role, but neither on their own can explain everything. All right, and so I wanted to take a brief moment and talk about critical periods. And this one was something I couldn't quite find a good spot to put it, and now that I've gone through the lecture, this maybe wasn't the best spot for it, but that's fine. And so the idea here is that there are critical periods in which we can learn language, and outside of those periods, we cannot learn language. I'm actually going to make a modification. We'll talk about sort of a slight change to that at the end here. But first, we'll talk about some evidence for these critical periods. So in some studies, mostly case studies, so say children who were raised by wolves or children who were abandoned and survived on their own in the wild, if they didn't learn language until much later in life, they struggled. They never had the same vocabulary. They never had the same fluency with language as sort of a native speaker who was taught from a young age. And if we see these isolation cases, if they were found younger, if they were found when they were, say, 5 or 6, they were able to acquire language and they could get back up to sort of normal functioning levels despite that isolation in their early years. So if they're young enough, they're able to overcome that isolation. But if too much time passes, then they can't. So that's our evidence for these critical periods. So there's some range where if you learn language before that, you're fine, and if not, you're not. And the idea here being that when we're younger, our brains are a lot more plastic. So we have plasticity, meaning that there's adaptability in our brains. And so that's why children are a lot more resilient for things like head injuries. So something that might cause permanent, irreparable damage to an adult might have no long-term effects on a child because their brains are still growing and evolving and developing. So as they're getting older, they're making connections between neurons, they're producing new neurons, and things like that. We still have some plasticity as adults, but it's a lot less extreme. So we can make new connections between existing neurons, but we tend not to have new neurons forming. So we are a lot less adaptable as we get older. So maybe that adaptability is what helps young children form these connections and learn all these new words. And in research that looks at non-spoken language, so they actually checked if there was this same critical period for sign language, and there is. It's much better to learn much younger, and if you learn older, you're a lot less likely to be fluent. But I do want to make a little bit of a caveat here, because the term critical period, when it was originally proposed, was meant to be sort of a hard cutoff, where if you learn it before this point, you're fine. After this point, you're never going to be fluent. But more recent evidence has found that it's less of a harsh line and more of sort of a blur. So we tend to learn things better when we're younger, and it's harder to learn when we're older, but it's not impossible. So instead, we use the term sensitive period. And that's because we are sensitive to acquiring that language younger, and that sensitivity goes away, but the ability doesn't. So it's like we're predisposed to learn during that window, and we can learn later in life, it's just harder. So sensitive period is a lot more accurate than critical period just because it's not as hard of a cutoff as what was originally thought. All right. And then back to our theories of language acquisition. This is actually putting the proper name to some of the concepts we've talked about. So we mentioned that Skinner was a behaviorist. So he was focused in on all of our learning and environmental factors. So they cared about environmental interactions and nothing else. Chomsky was focused in on our biological predispositions, something in our genes that allowed us to acquire language. And so he and people who thought like him were called nativists, basically because they said that language was innate, something that came in our genes, something that we would do naturally. And of course, as we said, it isn't sort of one or the other. We end up falling somewhere in the middle. And these are where our interactionist theories come in. And this is basically saying that biology and experience are both going to make important contributions. So we can look at sort of cognitive aspects, we can look at social aspects, and we can sort of bring it all together and consider it that way. So modern views are a lot closer to the interactionist perspective, where we consider both sides as opposed to one or the other. And we will eventually be looking at how sort of culture and language work together and influence our ways of thinking. But I wanted to take a brief moment and start talking about bilingualism. And this is fairly critical of a topic, especially within Canada, where we have 2 official national languages. So bilingualism is fairly important in Canada. And in fact, a lot of studies of bilingualism are done in Canada, simply because most other countries only teach one major language. And I have a really nice setup where my sister and I both took classes in English, and we had one French class each year. So we learned French a little bit from I think they started us in grade 2 onward. But my cousins, they both went to a French immersion school. So they were taught everything in French, and they had one English class. So we have sort of this nice box set of 2 and 2, where they were either primarily English or primarily French. And my cousins, they spoke English at home, so they still had exposure to English, but all of their schooling was done in French, which led them to be a whole heck of a lot closer to bilingual than my sister and I. And so, of course, the big question is, does learning 2 languages simultaneously cause problems? And there's some cases of yes, but there's also some benefits to it as well. So we're going to hit a couple of these high points. And we do see almost like we have limited processing power, or limited cognitive power. Oh, words today, where you can learn a certain number of words at a particular time. And if you're only learning one language, you learn all of the words in that one language. But if you're learning 2 languages, you'd split the available words between the 2. So in our 20 words a week, if I'm only learning English, then I'd learn 20 English words. But if I'm learning French and English, I'd learn 10 and 10. And so we do see that people typically have smaller vocabularies in one language. So their French vocabulary would be about half of what a monolinguist would have in their vocabulary. But the combination of both vocabularies, if we looked at both French and English, it would be comparable to the person who speaks only English, just for English. So it's kind of like they split those resources in half. And so that could be considered bad. They have less words available to them to get concepts across. But we do see a benefit here, and this is cognitive flexibility, and they also tend to have higher analytical reasoning. They're really good at selective attention, and even meta-linguistic awareness. So they're a lot better at flexible thinking and more intensive cognitive processes. And so a little bit of the theory here is that when you're learning 2 languages, especially at the same time, you have to kind of keep them separate. So your brain gets really good at saying, okay, we're speaking English right now, French is irrelevant, let's block it out. And so those blocking out processes help you focus, help you ignore irrelevant details, and give you that little bit of cognitive flexibility in the long run. And we're actually going to look at one of the ways that they test this ability to inhibit responses in just a couple of slides. But we can also say that there's a little bit of a disadvantage in terms of language processing speed for those who are bilingual. And again, this is probably because part of their cognitive power is tied up in inhibiting those irrelevant words and phrases and processes. And just like learning a primary language, learning a secondary language is a lot easier when you're younger. So the younger you are, the easier it is to acquire a language, regardless of if it's your first, second, or fourth. And we have this idea that greater acculturation facilitates acquisition. Basically, the more you're exposed to that language, the better you are at learning it. So where I was only exposed to French once a day, whereas my cousins had French all day, every day, they were a lot better at the language because of that increased exposure. And then at the end, we're having, okay, we have more executive control earlier on. So not only do we have that sort of higher cognitive ability, but it starts earlier. So we start seeing sort of the ability to inhibit certain responses at a younger age than if you didn't learn sort of 2 languages at once. And this was the diagram that I could have referred to back a little ways. This was just showing overall vocabulary size. But this is what I wanted to focus on, and this is one of our input inhibition tasks. So this is basically a setup. Usually you're going to have someone come in and sit in front of a computer. And so one hand would be on one key, so the X key is over on the left side. The 0 would be on the numpad on the right side. And those are just sort of easy to look at. And so here they're saying, okay, so the left is going to be the exact opposite. Red and squares. And then the right is going to be blue and circles. And they can ask you to pay attention to either the shape or the color. So if they tell you at first to focus on the color and a red circle comes up, you ignore the fact that it's a circle and you'd click with your left hand because that is the red shape. So you'd sort them based on the colors, and they'd look at sort of how quickly you can respond, how much interference is going on to block out those irrelevant features. And then if they wanted to get extra detail, they can actually flip the contingencies. At the halfway point, they'd say, okay, color is no longer relevant, sort based on shape. And so now when that same red circle comes up, instead of pressing on the left, you have to press on the right where the circles go. And so again, they can look at how quickly you make those decisions, and people who have learned a second language usually perform significantly better on tasks like this in all sorts of different iterations than those who do not have 2 languages. All right. And I was going to go into this slide, but I think I'm going to leave it here. That was just sort of saying that, again, it's better to learn a language at a younger age. So we don't need to introduce a new study to talk about that again. We will leave it there. And like I said, we're going to be doing Friday being an optional class. I'm going to bring in the midterms, and then we can sort of sit and ask questions and chat about stuff if you want to. If you do not want to, then you just don't have to come in. We are going to pick up with talking about whether or not animals can develop language on Monday, and then we'll transition over into how language influences thinking and so on and so forth. But yes, so we will leave it there.